Hello and welcome to the Tech for Climate podcast. I'm Guillaume, your host, and each week I'm fortunate to share with you stories from climate tech founders, investors, and corporations sharing their unique insights into this fast-moving industry. Eventually, like me, you will learn, discover, and get inspired by those unique men and women who are contributing to the fight against climate change, and I hope it will help you to take a step in this formidable movement. So before we start, I just want to share a few words about us, as this podcast is just the tip of the iceberg of what we do at Startup Basecamp to support the climate tech movement. Our mission is to accelerate capital deployment towards climate tech founders, allowing them to focus on scaling their solutions. How do we do that? Every day, we help founders access to resources and connection and gain the visibility they need to expand their growth. We do this in a number of ways with a membership platform, a Slack group with a growing number of founders, investors, and experts from around the world. And recently, we went one step further with the matching services to connect founders with top climate tech investors. Keep in mind that we are able to do all of this thanks to the support of our listeners and our members. So please like and subscribe, share one episode with a friend, join a community, and if you haven't already done so, make a small donation to support our work. It really means the world to us. And now, enjoy the show! Hi everyone, in this new episode of Founder Series, I have an insightful discussion with Martin Schichtel, co-founder and CEO of KRAFTBLOCK, which he describes as a multifunctional high-temperature energy storage system with the mission to decarbonize various industries. Having studied chemistry and completed a PhD in nanotechnology, Martin went on to develop materials as part of a research institute before falling into selling these types of products. KRAFTBLOCK started out as a hobby in 2008, which he approached in a very scientific way, spending 3 years doing extensive literature and market research before building the business proposition and launching it. Martin is also an avid reader and lover of nature, trail runs, and deep discussion with family and friends about theories he has read about and new ideas. Historically, energy storage has been discussed with electricity or battery storage in mind, however less so about heat, hydro, and sunlight. In this episode, we discuss different types of energy storage, new technologies, and how, if we want to really move away from fossil fuels for energy production, we need to ensure energy storage can be sustained through the nighttime hours and when the sun isn't shining or the wind isn't blowing in order to sustain lifestyles, industry, and wealth for the future. During the second part of the show, Martin shares his experience of his fundraising journey for a large-scale hardware company and some tips he wishes he knew beforehand. He also shares his advice for reaching a healthy work-life balance as a busy founder. Martin, welcome to the show. Hi, Martin. Welcome to the Tech for Climate podcast. I'm super happy to have you here with us today on the show. I believe it's going to be a great opportunity to hear your story and learn more about your exciting adventure with KRAFTBLOCK, which is a multifunctional energy storage for heat and power, and many things more. So we're super excited to have you here, and welcome to the show.
Nothing more to explain to you. Thanks for being me. Thanks for having me. Thanks for being here.
You're welcome. So before we start, that's a tradition on the show. Could you give us a 30-second introduction about KRAFTBLOCK?
Yeah, as you already said, KRAFTBLOCK, we call ourselves a multifunctional high-temperature energy storage system. Very complex thing, but at the end it's quite simple. What we want to do with our thermal energy storage system is to decarbonize various industries in order to help in the fight against climate change. That's pretty simple. What we do, we store thermal energy, so could be waste heat from flare gases, steel, glass industry, but we also could use electricity to convert it to heat, ideally green electricity, and then supply the suppliers with process heat to decarbonize in one single step.
So let's start from the top. I was on mute to make sure there's no background noise here. So can you tell us a bit more about your personal story and background? I mean, on the show we like humans more than the LinkedIn resume. So what are you passionate about? I mean, what do you love to do besides building KRAFTBLOCK? I mean, what makes you feel inspired or like your best self? As I always ask, who's Martin?
Yeah, in general, Martin is a quite curious guy, right? I love to learn about a lot of things. That's why I also love quite old literature, science literature from the 17th and 18th century, because those guys knew already a lot of things we already forgot today, but also could use or utilize today. I try to figure out what is the world about, right? What are the backgrounds? What are the ideas behind? And that is my main driver. Beneath that, I usually can think quite a lot, which I'm doing day by day, but I can do it very well doing sports, right? Going to the nature, having a walk around, having a hiking, doing trail runs, things like this, because this always opens my mind and makes me think in a quite creative way. Reading, of course, basically, I studied chemistry, took a PhD in nanotechnology, so I had to read a lot in my life and even keep on reading even books today, although there are fantastic ebooks and podcasts. But somehow the paper in my hands, I don't know, might remind me to my childhood or to my youth, what else it is. It's just a special feeling to have paper in the hands and read through those papers, do my marks in there, come up with new ideas, new minds. And especially what is very like me or it's me is discussing those ideas with different people. So really could be our secretary, could be my wife, could be my children, could be just friends and have very controversial discussions about everything. So um, I think I'm a quite mind-wide or mind-orientated guy, and that's basically most of my life.
So tell us a bit more about your, previous work and life experience before the launch of KRAFTBLOCK. I mean, what did you learn along that journey that, in a way, gave you an edge to start the company? Maybe you have like one or two pieces of like experience that you could define as like really valuable for the launch of KRAFTBLOCK.
Yeah, I think basically it's just, as I said, the curiosity is one thing to think about new ideas, new approaches, which was always a part of my work, right? As I said, I studied chemistry most of my life. I worked in developing different materials, especially ceramic-like materials. Also headed a research group of 40 researchers at the Research Institute to discover even more new things, which ended up in the industry doing sales for those types of products. So I was in combination of R&D and sales, direct contact with the customers to experience what are they looking for, what could be the next step, what could be the next stage. But what is interesting with KRAFTBLOCK, there was not a direct link to it. It was more an underconscious thing because I've worked in for sales in steel, ceramics industry, also a bit into the glass industry. So I've seen a lot of energy waste over there, just heat going out of the chimney into the atmosphere. But I never thought about this before. This came into my mind in a much later stage. But maybe it was just in my background, swiveling around and creating an idea in the future.
So, in all of that journey, and you mentioned this experience in more like the conventional industry and probably the more CO2 emitting
Yeah.
industry, being at the opposite of the spectrum here with KRAFTBLOCK. So, what have been this, your own personal, I would say, driver to jump into this more climate clean tech industry with KRAFTBLOCK? Any specific aha moment that you would recall or define as such, or maybe a succession of them?
Yes, there was, but it's more complex. I think KRAFTBLOCK is quite special how it came up with the idea. I worked on this idea already in, I think, 2008 it was when I saw a TV report about a concrete heat storage. I found it pretty interesting, cheap material cast in every shape. It stores heat, it's available worldwide. But they said they only can store up to 500 degrees C and it would be a high temperature energy storage system. I was working in steel industry at this time and this is kind of warm up temperature, it's not high temperature. And at that point, it was just a kind of scientific challenge how to figure out how to improve concrete, to have a broader temperature range, a better application spectrum, for various applications. But there was not a concrete idea to build a company at this point. So it took me like 3 years in a typical scientific approach. What is the problem? Literature research, trying to figure out how we could approach it. It was just, it's a hobby at the beginning. But when I made up my mind how a system could look like, I started looking into the markets where thermal energy storage used at that point in time, where could they be used in future. And so I dig more and more into this topic, and it got very well aware that in terms of energy demand, roughly 50% of the energy demand worldwide is heat demand. It's not electricity or fuels, it's heat demand. And then was a little bit like the aha moment. Hey, guy, you have seen it in the steel industry, you have seen it in ceramics industry. How many energy is wasted over there? What about all the fossil fuels that are burned? They are causing the emissions. And that was a little bit like how to say, like a purpose-driven idea moment, the wiki moment at this point in time.
Thank you for unveiling a little bit already this beginning of the story of KRAFTBLOCK. So before we go into detail about KRAFTBLOCK in itself, during this the pre-recording call, we said that we would like to cover a bit and understand the overall context that you are surfing on, and to put things back into perspective. Maybe I'd like to get your understanding of the energy storage problem and opportunities today, why storage is key for the energy transition at large. Maybe to start off, if you could share with us some data points regarding the needs of energy storage worldwide today, eventually the projection of the demand in the future, and where are we in terms of deployment to fill the gap in itself. And then we'll go one step deeper in terms of the current technology and then the upcoming one that you see. So here, really staging the whole context at first.
Mm-hmm. Energy storage, that's a quite interesting topic because let's say till 2 or 3 years ago, most people were thinking about electricity storage, battery storage. If they talk about energy storage, they are not talking about heat or heat storage systems or similar systems to this. But this is really a huge extension of this whole market. In terms of electricity, I think it's quite well explainable. I think we do have something like, 50 gigawatt hours installed worldwide at the moment and increasing at the moment. There are a lot of large-scale lithium batteries being built worldwide in order for grid services and things for this. We do have a couple of pumped hydro storages in the Alps, in Norway, in Sweden, a couple of countries that can afford this and have enough space to do it. But if we want to really move away from fossil fuels for the energy production, if we want to move to the renewables, I think there's no other chance than using energy storage, because simply spoken, everybody heard about it. The sun is shining as long as the sun is shining, and the wind is blowing if the wind blows. But there are a lot of times where there's no wind and there's no sun shining. So somehow you have to prolong the energy life also into the night hours, also into the low wind hours, in order to keep, at the end, our private lives up, in order to keep industry running, in order to create also wealth for the future. And that's why we need energy storage, generally speaking, for different applications.
So to go one step further, and thanks for already unveiling a little bit again, let's cover the existing landscape. If you could share with the audience, the main different categories of energy storage, and you mentioned the chemical one, the water system that can, for instance, in the Alps where you can make them drop. But what is used at the industrial level today? Can you maybe tell us a bit more about the different type of technologies that you see, and eventually the quantity of storage that they represent, if you have any data there, and maybe their advantage and limitation for the main ones?
Yeah, so I think the eldest storage we do have is the kind of pumped hydro storage or water storage, let's say water reservoir storage at the end, because it was always there. There was always a chance to utilize it. In ancient times, we always used hydropower just because of the decrease of the water angle at the end. So this is the oldest one. I think that's the most spread one for electricity storage worldwide. Actually, I cannot figure how the quantity is, but that's the largest quantity. And now it's followed up quite good by lithium battery storages. I mean, a couple of years ago, the Tesla storage in Adelaide with 100 megawatt hour was the largest one. Meanwhile, we do also have 100 megawatt hour or 200 megawatt hour storage capacity in Germany, and even increasing with the grid boosters. The same for other locations. Also, the US is building storages very, very fast, electrical storage very, very fast. So these are both, let's say, the original types of electricity storage. We had lead batteries in the past, could also be there today, but I think lithium batteries are much more efficient, much more compact. Okay, we can discuss about environmental impacts, but that's another topic. It's worse for both of them at the moment, but hopefully this will change in future. Then within the last 10 years, we have a couple of newer approaches, right? For electricity, we also do have redox flow batteries. We also do have a kind of molten salt battery, or how's it called? Thermal battery not in terms of thermal energy storage, but in terms of electricity storages, and a couple of other technologies approaching. We do have this intermediate between electrical storage and thermal energy storage, for example, what's offered by Malta X, storing electricity in terms of thermal energy, but using a special turbine system to regenerate electricity with a very good efficiency compared to typical steam turbine. So it's somewhere in between. And there we are already on the transition for thermal energy storages. Industrial-wise, the molten salt storage is the eldest one. It already was built in 1980s of last century in California with the first concentrated solar power plant. And exactly in this industry, those types of storages grew at the moment. But there is still roughly 30-40% of all CSP plants worldwide without any storage. So they are just producing energy during 8-10 hours every day, but not over the night hours. So a bit lax, though they try to refurbish it with thermal energy storages. For private sector, I mean, the best known is the hot water storage. A lot of people do have it in their cellar somewhere hidden. And that's also the issue with thermal energy storage. Usually they are hidden because they are not very design-like systems, but you put it somewhere in your cellar and forget about it, except there is some issue with it, and then you think about it. And this one in larger scale you find is storages for district heating, like seasonal storages to recover the energy over the summer times and distribute it over the winter times to the households. These are the three, let's say, the main categories that we see, or that I would see. A lot of new technologies are coming up at the moment. We are talking a lot about hydrogen, really perfect to see it as a kind of seasonal storage, long-term storage, even to replace gas. Methanization will be the next step through this with a higher efficiency, which all has its pro and its cons, right? So you can produce hydrogen, you put it into some cover and you can store it for 5 years. Perfect. If you burn hydrogen, again, you have a lot of energy losses beneath the generation of hydrogen, but you have energy losses by burning it. So it might not be the best solution for everything. And I think that's what's making the world quite complicated at the moment, that there is one storage solution for all application. There are a lot of niche solutions for different applications that it's needed worldwide.
So, looking at and double clicking a little bit on those innovation that you started to share with us, like it sounds that as we are, still in this emerging, I would say market in terms of like new solution and new technologies, and you can hear like often this new type of batteries or anode cathodes like really will change the way you store energy, and some people are using also like hemp and like it can be sands and can be like so many different innovation, but which one, according to you, besides what you guys do with KRAFTBLOCK, and we'll go a bit deeper just after this, but which one is like the most realistic today in terms of like, or I would say ready to scale, and in which timeline one or two of those solutions will, in a way, take over a large portion of the market and at the end of the day, support this decarbonization effort that we are all working on?
Yeah, I think we have to do a split in the different storage systems. I mean, the pumped hydro storages that are ready to scale, quite old technology, but there's just limited space worldwide where you can put pumped hydro storages in a quite smart way. We do have let's say gravity-based storages. We all know from different players in the market that are ready to scale. Quite simple technology at the end, a lot of proven components. The whole system might be quite new, but it's just adding 1+1 is 2 in some, which is the same for those gravity-based storage. So easy to scale it even at the moment. For lithium batteries, for example, I think the technology is quite proven in the market, especially if you think about electrification of cars, where the environment is a little bit more harsh than having a stationary storage somewhere put in the grid, which does not move, which does not have any vibration frequencies and things like that, so easier to handle. Can also be scaled, but now it's depending on on the costs, which is one fact for those systems. We do have the redox flow batteries. I think the first large 100 megawatt hour, 200 megawatt hour systems are under execution at the moment, which is a great step, first basis for scaling. But if you think about capacity storage, especially for grid purposes, it's just too small. But if they modularize it and scale just the modules, then it's also kind of easy scaling. We see hydrogen, of course. There are a lot of more electrolyzers coming, which is pretty good. What we do not see that much is really hydrogen storages or hydrogen grids to distribute the hydrogen based from a central storage to different solutions. I think this will take quite its time, like 5 to 10 years, till it's fully established in the market. For off-grid applications or island applications, that's also a good option to use it, especially if you also utilize the hydrogen as a raw material for your production itself. So you have a combination between energy storage and raw materials. I think this is also pretty much, especially in the island stage, based to scale. Then if you take a look to thermal energy storages, molten salt storages, as I said, quite old. They are already in commercial scale available, but not suitable for all of the applications. They're limited from the temperature range, also from the footprint, which is very important for a lot of industries. And then we are at storages like ours, or the sand storage you mentioned, or broken rock storage, or storage based on concrete, which all worldwide, as we see, are just now taking the first steps in scaling. So we see applications like 0.5 megawatt hours, 4 megawatt hours, 10 megawatt hours. We are working on a 150 megawatt hour system at the moment. But I think basically the approach from those players is, let's say, quite settled and quite proven. So building modules, and then you just think about how often do you multiply this module in order to scale it. The biggest obstacle at the end is the acceptance by the customer, right? So what we see, there are a lot of technologies at their starting points ready to scale, but a lot of customers asking questions like, is it already under operation for 10 years, for 15 years? We need the reliability, we need the security that it works. It's a little bit like the mindset topic.
Mhm. I think this is a good segue for my next question. I mean, now that you understand a bit better the problems, the limitation, as well as some potential alternatives here and solutions. So to get a more complete understanding of the context, if you could tell us a little bit more about like those actors, like in the energy storage market, we understand it's very fragmented and completely distributed. But do you see like few of them are that the emerging large players? I mean, we know that the Tesla of the world for sure. But what are the, maybe that correlated to that is like, what are the limitation or the small barrier for upcoming technology and new startups to penetrate this market? I mean, how is the market organized there?
Yeah, well, also not that simply organized, unfortunately. There are a lot of players, a lot of utilities, a lot of corporates in the market thinking about thermal, and generally about energy storage solutions. Meanwhile, I think they are quite close at the end of their benchmarking phase, which means they took into account different types of storages, took a look on different customers from their side to see what is the best storage application for which kind of customer. And that's the fragmented devices, as you already also spoke about. That makes the system quite complex. But I would assume there's another 1 or 2 years until they are ready to go and ready to deploy storage installations in various systems. What we definitely see is a kind of, how to say, an external driver for this whole topic to get a good traction with energy storage is that's the final customer, right? I mean, I'm not the youngest generation, but I also think in terms of sustainability, you want to have sustainable products, decarbonized products, things like that. But our youth, that's a major driver. And if the youth says, for example, I don't want to eat any snacks anymore, which used to produce carbon dioxide because it's an issue for me in terms of climate change, then the industry does have to react. And so we have a driver from the end consumer towards the industry, towards the utilities, towards the corporates to say, I do not sell my products anymore in the future if I do not change anything. So let's think about how can I change my system today? What is technology? And then they are start thinking about let's try those technologies which are not fully proven in the market because they are just at their very beginnings of their developments. And that's where we are today.
Mhm. So to close this section, if you could tell us a bit about the current regulatory framework. I mean, what are the regulations currently in place? Or the missing ones that could be blocking or slowing down to reach this, I would say, theoretical goal of zero energy loss and 100% storage capacities. I mean, do you see any difference also between the EU, the US, Canada, and the rest of the world?
Yes, between EU, US, Canada, definitely also inside the EU, it's quite different. If I see the regulatory framework of Germany compared to the Netherlands, for example, it's quite different. Also, it should be one at least or covered by one overarching framework from the EU. And so it's different in many countries. Also the same for the energy generation costs, right? I can buy electricity in the US from PV for 2 cents or 3 cents per kilowatt hour. Could be the same in Germany, but we do have grid fees, we do have taxes and things like that on top of it, so that you end up with 26 euro cent per kilowatt hour of energy. This is one of the levers you have to say for the state, okay, we do not charge that much taxes on it, we do not charge that much grid fees on it to make electricity more attractive and to electrify more and more in the future. There could be another driver which we only see in some countries, like in Denmark, in Finland, in Sweden. Also, US is starting with with their new system, or in Netherlands would say fossil burners like gas burners, oil, coal burners are not allowed anymore from 2025, 2030, 2045 onwards into the future. So they are forcing everybody, private homes, but also industry, to think about alternatives. And that's what we can see today. If they want to increase their production capacity, they already have to introduce alternative systems today, which is one of the main drivers. And I think that's pretty necessary because industry usually thinks in terms of margin, in terms of benefits, in terms of good economics, but they have to understand that they have to invest in capex today to save opex tomorrow. Means on one hand they have to invest more today, which is bad for their balance sheet, but on the other hand there will be a better impact, a better future tomorrow for them. And they are on their way in doing this. And states, regulatory departments can enforce this thinking by saying, okay, stop here, no way to go over this line. You have to think about the change.
Thank you so much for all of those super valuable insights on the ecosystem in itself and this macro view as well. So let's go deeper into KRAFTBLOCK. You already uncovered a bit, but we love to hear a little bit like the story behind it and which gap did you identify initially. And you mentioned that based on your previous experience as well, that led to the current version of KRAFTBLOCK. I mean, as I always ask, like, why did KRAFTBLOCK have to exist?
Okay, where did we come from? I already mentioned it. It was a kind of scientific challenge how to improve a concrete heat storage, because I thought heat storages or thermal energy storages are pretty well needed, especially for concentrated solar power, also for district heating systems, things like that. At that in that times I didn't think about industry very well, which was coming to the mind later when I did the market research about storage systems itself. We started with KRAFTBLOCK in 2014, quite a long while ago. But at the end, it was just with the idea, right? There was no fully developed storage material. There was no storage system. There was no contract with a potential customer. A lot of talks with potential customers, of course, but nothing ready to go. So we fully developed the whole system from the storage material till it is, as for today, by ourselves over this time. And it's hardware. It's massive hardware. It's a kind of mini power plant that was developed over there, and it takes its time. So I would like to have it in 4 years, but it took 8 years, which is still 2 years faster than we expected it to be. So quite on a good track. The main purpose at the beginning was to say, let's introduce this type of storage to concentrated solar power industry, because it's pretty well known that especially the solar towers can produce temperatures of over 1000 degrees C, which would be perfect also for industrial applications. But unfortunately, it's shown out that most of those towers are operated with molten salt, which is limited to a temperature. So, and their molten salt storage is already installed, so there was no really chance to introduce a new type of storage. Maybe for future purposes, for future applications, but not 2014. So we did a kind of reorientation. It's not fully true because we already had in mind waste heat recycling at that point, but not a focus on this. So we dig more into established industries, energy intensive industries like steel, like glass, like ceramics industry, cement industry, petrochemical industry. Why for those industry? And why industry in general? That was a very concrete decision for us, because we said if we can decarbonize just one site, we will have a huge impact. We need a couple of thousand private homes to decarbonize in the same way, having the same effect than in one industrial site. That's why we focused on industries from the very beginning. And the high temperature range, and there comes in to the mind my previous experience before selling products to those industries, because I have seen a lot of energy waste over there. And if you think about, let's say, a modern furnace, a modern kiln uses 50% of the energy, for example, for your mug itself, and the rest of the energy is waste energy going through the chimney or through the exhaust system itself. Then there is a big potential to recover this energy, reutilize the energy. Means on one hand you save emissions, on the other hand you save primary energies, which both fits to the targets we do have, massive decarbonization of industries. And that's why we first took a look to the steel industry and petrochemical industry. I think it's quite obvious. If you pass by a steel plant, you see this wonderful flame burning into the atmosphere in a lot of steel plants. This is the flare gas stack, which is just flaring the produced coke oven or blast furnace gas from the steel production itself. They do not store it, they cannot store it in these massive amounts. They flare it. But in a small steel plant, these are already 300 gigawatt hours every year. And 300 gigawatt hours is enough to supply 16, 20,000 private homes the whole year long with thermal energy. And now you have a little bit of a relation on seeing this wonderful small torch, which is in reality 50, 60 meters in height, and what the energy content is. And so for us, it was obvious to say, okay, let's start in steel industry. Let's take a look to all the other industries that are operated furnaces, kilns, oven, because it's always the same principle. Part of the energy in the product, the rest of the energy is waste energy. And that's where we started, basically, waste heat recovery for different industries. And we dig very deep into this ecosystem of different industries. Yeah, that's what we did more or less the first 4 or 5 years of our life, in order to fully develop our product for the customer's needs, right? We had a vision of the product, what it should be. We are still not there where we want to be, still further developing, but we already now have a product which is perfectly fine for most of the applications we do have in mind. On this journey, we also saw more and more electrification of the system. So we talked about electric arc furnaces in steel industry, electric arc furnaces in ceramics industry, which operates in a different way. But it's electrification of heat, right? And that's why it comes into the mind very fast. How can we electrify heat? How can we take this heat into our storage? How can we utilize it for the customer? So at the end, we do have one thermal storage with 2 different applications. One is waste heat recycling, the other one is electrification or net zero heat how we call it today. And now 2 more assumptions. Our basic assumption was to say we want to have a modular system, a fully modular system, in order to be able to scale quite fast, in order to be able to combine our storages as it's the best way for the customer. So not having, let's say, a special construction, a special engineering for each customer, but the basic set of, let's say, building blocks, how to build a large-scale storage based on the same modules you would use for a small-scale storage. That was one assumption, and that worked out pretty good. The other one was to say, should we integrate any components into our storage device, or should we create a charging device and a discharging device to operate the storage? And we decided for the last point. Just why? Because most of the equipment you need to charge the storage and discharge the storage is out-of-the-shelf equipment. You get it in the market. There are tons of references in the market. You only have to do a kind of smart engineering to bring everything together to an energy system. The second reason is, if I do not integrate any component into my storage, I do not have to take care about the component itself. So what do I mean? If I want to produce steam based on stored heat and I integrate a steam generator into my storage temperature will also always be limited to the type of steam generator. Means if I produce 200 degrees steam, I could not charge my storage at 1000 degrees C, because I would have a lot of issues with this component inside, because it's not layouted for those temperatures. That's one of the reasons. The other reason is, as I said, scaling. Now I can take my modules as building block and build a 1 gigawatt hour storage based on the same modules as I do it for 4 megawatt hour storage, which is not possible if I integrate components, because then I have to think about how do I combine those components, how do I scale those components as well. Means with those basic assumptions, we already did a quite good job, and that's really appreciated also from our customers.
So I think it's a good segue to move on more on the product side. I mean, if you could walk us through the process. I mean, how does it work? How much energy can you store in each module, and how large can you go? I mean, how many modules in theory you could aggregate together? I mean, you choose like heat as a storage, means, and then from that heat you can inject the heat within the industrial system or produce electricity, if I understand well how you do it. So, I mean, what is the energy required to load that unit as well? I mean, are you like, how much is lost into the process? I mean, if you can help us visualizing this whole process, and we're on a podcast, so it's easier to really understand step by step. And then maybe you can take a use case of one of your current pilot projects. That's going to be even easier for them to understand.
Yeah. So let's take a look at those both use cases I just mentioned, right? We do have 2 different heat sources, but one application which is heat for industrial processes. Not talking about electricity to electricity now, but just for heat applications on the customer side. We do have waste heat recovery, and we do have electrification of heat. In terms of waste heat recovery, the easiest thing we could do is using an existing waste heat stream, so flue gas line, which is already existing on customer side, and integrate our storage more or less into this flue gas line. It's done by a bypass, of course, but it's an integration into the flue gas line, so that the flue gas directly goes through our storage. Our storage materials absorbs the heat, then we shut it down and release the heat by blowing cold air through the storage, taking the heat out of the storage and going to the application. That's the easiest way. And then you can talk about efficiencies like 96, 97% or even more from heat to heat, though there are only few losses. Could be also quite complicated because you have a lot of pollution in a flue gas, a lot of dust in your flue gas, which will clog the storage device itself. So you have to think about heat exchanger in between, which will lower the efficiency, but still you would be higher than 95% of efficiency in this process, especially if you stay at heat in the upstream application itself. If you talk about electrification, it's also pretty interesting because converting electricity to heat still does have an efficiency of 98 to 99%, right? Only losses of 1 to 2% for this electrification step. So we end up somewhere between 94, 96, 97% of thermal efficiency of the whole system, which is really pretty good. If we think about electrification, so storing electricity in terms of heat and releasing electricity, we do have the bottleneck today that the electricity generation just have a maximum efficiency of 45, 46, 47% if you have a large-scale steam turbine. If you use an ORC, it might be 15 to 20%, Stirling like 10%. So that's the bottleneck in electrifying heat again. But and that's how we look on it, and also utilities start looking on it. It depends a little bit on the time scale, right? If you look at a short-term time scale and you say, I have to invest in a power-to-heat system, I have to invest in a thermal storage, I have to invest in a turbine, nobody would do it, because if payback time should be 5 years, no way to go. But if you think about such a system being a kind of power plant, and the service life of a typical power plant is 30, 40, 50 years, and you just take into account 20, 25 years of service life, then you got an interesting use case, even if there's the bottleneck of 45% efficiency of the turbine. We have seen it in a couple of studies with STEAG in Germany, with AGL we just executed in Australia, that the levelized cost of storage, so how much does the energy in the storage cost when it's discharged, is better than lithium batteries. Why? Because you have to replace the lithium batteries at least 2 times over the service life of 20 to 30 years. So the capex is just exploding. While our system will still be under operation over this time, and from some time on they will earn money. So electrification, it's quite a positive thing. We see it in not in the short term, but in mid-term, like 5 to 10 years, first projects coming out.
So double clicking a little bit on the, I would say, inside of the heart of the block in itself. Could you help us to visualize a little bit, like how does it look like inside? I mean, I saw some videos on your website. It looks like there's like those, the same, I would say, stones that you use for like pizza oven. If I go on the easy way for everybody, but how does it work? I mean, like, what are this? And you mentioned also those upcycling materials, those little balls that you guys put inside. I mean, where do you source them? What are the logistics required and constraints behind that? Help us to visualize this secret sauce that you have there.
Try to make it not that complex. What was our approach? First of all, to develop a new type of storage material. I mean, there are a lot of people out saying, you don't have to develop something new because it's already existing in the market. That's true, but we are convinced that we cannot solve the problems of the future with the technologies of the last century. So we have to move on, we have to take it to the next level. And that's what we try to do also with the storage material beneath the whole storage system itself. Our approach to the storage material was basically to say sustainability. It's very important for us, for not only for the company itself, but for the whole storage system we offer to the market. And that's why we try to take back to circular economy as much as possible material which are usually put on dump or disposal sites, right? That's why we took a look strongly what is put over there. Steel slag, for example, that's one of the major components in our system. And there's another aspect with a technical one. Steel slag, it's available worldwide. We do have more than 400 steel plants worldwide producing exactly this type of slag that we are using, and this for 30, 40 years. So there's no supply chain issue. Even if we would build a production in China or Australia or Brazil or where else, all over the world, there are those types of steel slag available. And as I said, deposited for at least 20, 30 years. So enough available also for the future. No issue about that. But the steel slag does have a good heat capacity, but a worse heat conductivity. What does it mean? If this would be a crane, a steel slag pallet, and I heat it up from the surface, it takes quite a long time till the heat penetrates into the core of the storage, of the material itself. And this is totally brutal for technical applications because you have to charge fast and you have to discharge fast. The customer cannot wait for half an hour till your system starts discharging. It needs to be done within seconds or even within low minute range. That's why we said we have to increase the conductivity for the whole system to have this technical approach, to have an option to tailor the storage material. And that's why we combine those upcycling materials with a special type of binder. And now we are able to control, do we want to have better capacity? Do we want to have better conductivity? What is the best ratio for which application? And that's just the start behind the materials, a bit behind the material science. And having those, try to find a picture, try to imagine such a pallet. It looks with 20 millimeter, 40 millimeter pellets that we use. It's a little bit like a swamp. So the structure of the swamp, it's the binder, and the hole in the swamp, these are the capacity fillers, the slag, for example. And then you can imagine that you have heat transport ways deeply into the core of these pellets. And that's why we can heat it very fast and cool it down very fast and react to any technical requirements you do have. Mm-hmm. So this is the material. Using pellets, we do have a high surface, and usually the surface is exactly the component which is used for the heat transfer in between the storage material and the heat transfer media, like hot air, like flue gases. So it's also important to have a huge surface area, and that's what we are having. And then you do a quite smart combination inside the storage containment itself. So there's a lot IP in that, so I cannot figure out the details of this. A lot of things more that are coming, but at the end, our storage is an outer shell. We do have a static system that is which takes the whole static load. We do have the insulation. We do have our storage material. We did not integrate any moving parts. There's no flap. There's no valve. There's no compressor. Nothing. It's just the storage.
Mm-hmm. Yeah, so I believe for the maintenance and the lifespan of it, it's definitely a big advantage. Do you have any idea about like the lifespan of those components and those like little like steel slag balls? I mean, like, do you estimate that they need to be changed or replaced or refilled every 5 years, 10 years, or is it something that in theory could last forever?
So what would be nice, it lasts forever. I mean, if you take a look on our website, I think there's infinite lifespan written somewhere. Could be infinite, it depends on how you define infinite at the end. We have tested our system for 15,000 cycles, so charging and discharging, which took us all a bit of time of our lifespan. But we wanted to have this cycle testing because if you just counter-calculate one cycle each day, 15,000 cycles, these are nearly 40 years of service life. And that's what the storage system is made for. As we did not integrate, as I said, any components to the storage, all things like blowers, fans, like heat exchangers are outside the storage, so they can have their standard maintenance as industry is used to it. So really no constraint for a long service life.
Okay. In terms of regulation and certification, anything that you guys had to go through or like applying for, still waiting to get, or it was like something very straightforward and ability to collaborate with any different plants or industrial potential clients?
Yeah, usually we are applying all the worldwide standards that are available. So typical DIN, EN, ISO norms, typical mechanical engineering standards, material standards. So we do not invent anything new, especially at the interface to our customers. And it's fully standardized. So really there is nothing new we invent. There are a lot of industrial specific standards or site specific standards. That's the most worth point to discuss with the customers. What internal standards do you have so that we can comply also to them, but that's absolutely no issue. That's a proper engineering. We are based on ISO 9001, so also do have this certification system in place. That's not a problem at all.
And just last question on more like the technical side, like, I mean, each module, what's the capacity that you can, in theory, in terms of that you can have, and like, how many of them would you be able to, in theory, aggregate together? Is it infinite, or there's like you're reaching like a megawatt, terawatt, or what's the?
Yeah, we are starting in the megawatt hour scale. So 20-foot storage means 6 meters in length, 2.3 in width, and 2.4 in height, including the static structure, including the insulation. Still does have a capacity of 8 to 10 megawatt hours thermal at 1000 degrees C. It's also at 800 degrees C, it's a little bit higher at 1200 degrees C, but it's the, let's say, the average capacity we are calculating with, and that's just one storage module. The largest storage we designed for a customer at the moment based on those modules is 7.6 gigawatt hour of storage capacity. A feasibility study which is going on right now. What is very special about our approach, we never would build one single 7.5 gigawatt hour storage unit. We always would modularize them in smaller units because we see a lot of technical advantages if we do that. First of all, if there's just one unit and it fails, the whole system stands still. And it costs a lot of money to take it into operations again. The second point is, if you would only have a partial charge of the storage, you would have a massive degradation of the temperature inside this large vessel. Means you might not have the temperature necessary for the upstream application. The third point is, if you build just one large containment, you only can charge or discharge. You cannot decide between charging, discharging, bypassing, or what else is needed to operate the system. That's why we modularize it to smaller scales. For example, I think the 7.5 gigawatt hour system consists of 50 different modules, smaller ones. Also with an additional benefit, you do have 50 different charging and 50 different discharging systems. Sounds very complex right now and very expensive, but it isn't, because those are out of the shelf components. There's not a supplier which has to design a power to heat system for 7.5 gigawatt hours charging, right? We're using what's existing in the market. So it's cheaper, and you have a kind of internal redundancy. Means if one system fails, there are still 49 under operation. The same for maintenance. You can take out one system for maintenance purpose and keep the other ones under operation, which means you increase availability, reliability, and the uptime of the whole system. So that's our basic approach to it.
Yeah, and I think it's very interesting, this compartment block approach, where definitely helps to avoid the whole system shutdown. Last question on technical side before going into the business model. Just out of curiosity, I mean, when you fully charge at 1000 Celsius heat inside of your block, how long that heat lasts, and what is required to maintain the heat, or how long do you have before you start to see a drop in terms of because I guess the heat is not forever stored in there until you need it.
No. It's definitely not a seasonal storage, so you cannot store it for a month at the end. But you can store it, the maximum we calculated was for 2 weeks in a large scale system, which is already pretty good for a thermal energy storage system. Usually a storage device like KRAFTBLOCK or also another storage device is used to store heat between a few hours and a few days. And that's the typical cycle of heat. We do a quite close and intense analysis of the needed insulation. So this is pretty much a lot of engineering work, but we want to deliver maximum capacity to the customer and not a standardized insulation. So an insulation, if I design it for 1000 degrees C, 72 hours standstill time, does not make sense if my customer just has 500 degrees C and needs to cycle it within 6 hours. I lose a lot of storage capacity. That's why the insulation design is done project by project at the moment.
Okay. Thank you so much. So what are the current and expected economics of KRAFTBLOCK? I mean, how much does it cost to use your storage system versus other alternative for heat or chemical-based solution on the more electricity spectrum, I believe? I mean, maybe can you tell us a bit the business model that you guys have, eventually some clients that you already onboarded, and the future projection?
Yeah, of course. So we do have, again, coming back to the split of the system, saying waste heat recovery on one hand, electrification on the other hand. We are active in both sectors. The first customer in waste heat recycling was in ceramics industry. So this company is producing grinding wheels, but not the small ones for the do-it-yourself market. It's more the large ones for steam turbines and a lot of large-scale equipment. They are the third largest grinding wheel producer in Europe at the moment. And there we do just a simple waste heat recovery, so taking the heat out of the flue gas when the oven is heated up and heating, and we recycle the heat back to the oven when it's ramped up the day after or the 2 days after. So it's a batch-driven process. Storage is a perfect application for this. And this is Comet in Germany. We do have another customer or two more customers in steel industry. Unfortunately, I cannot name one of them yet, but I think there will be a press release shortly where we designed and executing a system for waste heat recovery at the Sintercooler station, which is also a pretty good application. A lot of energy is just put in the atmosphere in this process. And there's a third one in Germany where we install a thermal energy storage system where we recover the flare gas heat, which is at Saarstahl in Saarland at us. So there are already a lot of good experiences, a lot of more customers approaching at the moment. Electrification, especially in Germany and Europe, that's the top tier application at the moment for thermal energy storages as well. I think the largest system probably is quite well known, which is the one for PepsiCo and Eneco in the Netherlands. In this case, we replace a gas-fired boiler in the final stage, a 25 megawatt gas-fired boiler against an electrified system. They are using the gas-fired boiler to produce the Lay's potato chips, just to fry it at the end. And in future, so next year, they will use our storage system to produce the Lay's potato chips, and it's fully electrified. Means our system charges for roughly 4 hours every day when the electricity prices are very low, but is able to discharge 24/7 to the application on PepsiCo side, which means this process line will be decarbonized by 98% in one single step, and that's quite brilliant. And a couple of more customers like this, I think we will see within the next months when we are able to talk more about it.
Definitely, but thank you so much for already unveiling all of that. So I would ask you then, how are you guys planning to scale your operation? I mean, what are the steps that you see to achieve it? I mean, what needs to happen? What's next for KRAFTBLOCK?
I think next for KRAFTBLOCK is the reaction of the market, mainly. So usually we are saying, and it's really not kidding, it's my conviction, that all of the players with thermal energy storage are meeting the same customers, because there are only a couple of early movers, early adopters today. But there are a lot of followers already waiting till the first real live commercial scale applications are under operation. We can see it also in our inbound requests from various industries, especially also from the food industry at the moment. That's just, let's say, the limiting factor. As soon as, for example, the PepsiCo plant is under operation. And not to say there is no limit, there will be limits, of course, but then the market can grow much, much faster. And I think the reliability also for our competition is much better if there are larger scaled commercial systems in the market and shown its reality. It can be done, and we can decarbonize with those systems. But that's our mainstream where we have a look on scaling. Yes, it's an interesting fact. We already have built our own production lines in Germany, so we are able to produce up to 1.5 gigawatt hour of storage material every year with one single production line. The same at least for the thermal energy storage device itself, so the different modules. So pretty well equipped for the next phase that is approaching. And we developed a quite interesting scaling concept, which means that we are teaming up at the moment with a lot of players in the market, because our aim is not to build all the storage units in Germany and ship it to Australia, for example, but to be very close to the site the storage should be installed in future, also in terms of transport costs, transport emissions, things like that, but also having in mind, and it might sound a little bit strange right now, is the social impact, right? If we can utilize workforce quite close to the spot, we also can have an impact over there, not just, let's say, earning money and not having additional impact to the carbon dioxide emissions.
Exactly. What's your personal opinion on the climate crisis? I mean, what would you say to people who feel overwhelmed and demoralized by all the visible consequences that we're already having today? I mean, as I always ask, are we doomed?
That's a good question. No, personally, I'm a quite optimistic guy. Whereas I do have a little bit the optimism definition mixture out of sightings and Douglas Adams, saying my definition of optimism is jumping from a cliff and not trying to hit the bottom at the end, means learning to fly. And I think at least on the technical side, we do have all the options to fight the climate change, but they have to be used in a very broad way. So we need a technology openness to introduce all those options to the market. We cannot revert the defined kipping points as it is today, but passing this kipping point also does not mean the worst case will happen. It will happen a little bit faster, but not finally. We still have a chance to convert the system. That's one of the points. The other point is, of course, people do not like to change their status as it is, independently what it is, whether it's wealth, whether it's where they live, whatever, or their personal habits. But I think they are able to do it. And once, if they learn to do this, it will also have a massive impact. So, no, definitely, mankind will survive. So, in one way or the other way, I'm quite positive about that.
And maybe on Mars, we'll see. But hopefully on Earth as well.
Let's back on SpaceX and Mars. Let's see.
Exactly. Elon, here we go. Now, thank you so much. So how can all listeners of, funders, investors, experts around the world listening to the show can help you?
First of all, it's very, very important to spread a word about solutions like ours, right? Because only if it's known, people want to learn more about it and want to use it. So we have seen it, especially in Europe with the Ukraine war and the gas crisis we had, that industry suddenly start thinking about electrification and getting rid of the gas. And they learned a lot about thermal energy storage systems as well, because they are quite efficient way to use electricity in order to produce process heat. Increasing our network is always very, very important to us, because it takes quite a long while till a customer starts to order a process. So you have first to build trust, you have to talk to them, find a solution for them. Then it's a new technology, they have to think about their budgets to build the budgets. So also the network is pretty important to us. Might also sound strange, also network to potential competitors or new startups in this sector is very important to us. Just give you an example why. Our solution, for example, is not dedicated for the low temperature range, like 60 degrees C, 80 degrees C, 100 degrees C. It's not dedicated for replacing molten salt, for example, in special applications, because molten salt delivers a steady temperature interval for a longer period in time. Can be done by a sensible storage, but it's harder to do. So we usually try to team up with those companies or say to the customer, look, there's a better solution over there. It's important to have the impact at the end to reduce the carbon dioxide, whatever means it takes.
Any question that I did not ask you that I should have for this first part of the interview?
No, actually, I cannot remember whatever I talked about, but no.
All right, thank you so much, Martin, for your time, your incredible insights on the industry. I'm so excited to see so many brilliant people like you putting so much time and effort and willingness to create a change for a better world. So thank you so much for joining the show today.
Thank you so much for being here, Guillaume. It was really fun.
Thanks again for joining us on the Tech for Climate podcast. I hope you enjoyed the show. Stay tuned next week for more climate tech insights. In the meantime, head on over to our webpage at startupbasecamp.org, where we have lots more insights and resources for anyone wanting to get involved in climate tech. If you find our resources useful, please consider donating to support our small self-funded team. Don't forget to subscribe and share with your friends. And see you next time.